$500 billion. That is the combined valuation of every active lunar mining contract, every space resource projection, every asteroid mineral rights agreement currently sitting in the portfolios of the largest private space companies on Earth. $500 billion built on a single foundational assumption about what the moon actually is. That assumption is now wrong. And nobody on CNBC is running this number right now. Nobody in the financial press is explaining what it means when the bedrock data point underneath an entire emerging industry turns out to have been incorrect from the beginning. Because explaining that would require admitting something that every space economy investor and every government space agency on Earth desperately does not want the market to price in yet. The moon is not gray. It never was. And the moment that fact finishes propagating through the mineral survey models, the extraction cost projections, and the logistics frameworks that $500 billion of capital is currently resting on, the reckoning is going to be extraordinary. I am going to show you exactly what happened. Not the press release version, the geological and financial version, because the math here is devastating, and the math does not lie. This is the Asian space guy. And today we are going to do what nobody in the space investment space wants to do. We are going to run the numbers. Here is what the official story looks like. For decades, the moon has been represented in scientific literature, in NASA mission planning documents, in the foundational data sets that every private lunar mining company has used to build their business models as a gray body, gray regolith, gray surface, gray mineral composition. The iconic images from Apollo, the training simulations, the geological survey maps, all of it built around gray. The gray assumption was not arbitrary. It was based on the best available data, which came from Earth-based telescopic observation, spectral analysis at distance, and the limited sample return from Apollo missions. Those samples were analyzed, cataloged, and the results were fed into every resource projection model built over the past 50 years. The entire industry knows exactly what gray lunar regolith contains and how much it costs to extract it. That knowledge is now outdated, because astronauts sent to conduct fresh surface assessment have reported something that does not match the models. The moon is brown. Not metaphorically, not in a limited localized area, not, and as a minor regional variation. A significant portion of lunar surface material appears brown when examined in direct sunlight at surface level, a coloration driven by the presence of pyroxene and olivine minerals in concentrations and distributions that the existing gray assumption models did not account for. Run the first number. The entire framework of lunar mining economics is built on gray mineral composition data. Pyroxene and olivine are not the same as the mineral profiles that gray regolith models were designed around. Different mineral composition means different density. Different density means different extraction complexity. Different extraction complexity means every single cost projection in every single business model currently operating in the lunar mining space is wrong. Not slightly off, structurally wrong. Because they were built on the wrong rock. And here is where it gets extraordinary. The gap between gray assumption economics and brown reality economics is not something that can be corrected with a spreadsheet update. It requires rewriting the mineral maps completely from scratch. The estimated cost of the new survey missions required to generate accurate mineral distribution maps of the lunar surface based on actual observed composition, $2 billion. That is the price of finding out that the foundational data set was wrong. $2 billion just to get back to the starting line with accurate information, before a single ton of material has been extracted, before a single extraction vehicle has been redesigned for the actual mineral composition, before a single logistics cost has been recalculated. So what actually happened here? Because NASA did not lose the original Apollo samples. The spectral analysis teams did not make a simple arithmetic error. The telescopes were not pointed at the wrong coordinates. Something more fundamental went wrong. Something that cuts to the core of how an entire industry built its projections on data that was never capable of capturing what it needed to capture. The Apollo samples were real, but they were limited. 382 kilograms of material returned from 6 landing sites across a surface area of 38 million square kilometers. That is one sample site for every 6.3 million square kilometers of terrain. If you tried to build a comprehensive mineral map of the entire continental United States using 6 soil samples taken from 6 cities, and then priced a nationwide mining operation on that map, you would be working with the lunar mining industry's level of geological certainty. The color observation is not just aesthetically interesting. The brown coloration from pyroxene and olivine is a geological signature. It tells geologists something specific about how those minerals formed, what temperatures and pressures shaped them, what their internal crystal structure looks like, and critically, how hard they are to break apart and process. Harder, denser, more complex mineral structures cost more to extract, more to process, more to transport. Every variable in the cost model moves in the wrong direction simultaneously. This is what geologists call a compositional surprise. And compositional surprises at this scale do not stay contained inside geology papers. They propagate into financial models. They propagate into contract valuations. They propagate into the equity prices of every company that built its prospectus on gray regolith extraction projections. And they propagate fast, because the moment this data becomes the consensus scientific position, every analyst covering the space economy sector has to revise their numbers downward. Stay with me, because this is where I need to show you that the financial exposure here is not abstract. It is sitting inside funds, inside institutional portfolios, inside government agency budget allocations right now. The companies affected are not small. They are not fringe operations run by optimistic engineers in garages. They are backed by sovereign wealth funds, by defense contractors, by the largest aerospace companies on Earth. Here is the exposure map. ISpace, the Japanese lunar mining startup, has raised hundreds of millions and has active mission planning built on existing lunar resource models. Astrobotic technology, backed by NASA contracts worth over $100 million, has mission architecture predicated on known surface composition. Intuitive Machines, a publicly traded company, has contracts and mission plans tied to existing lunar resource frameworks. Every single one of these organizations has a financial model with the gray assumption embedded somewhere inside it. And above them sit the government programs. NASA's Artemis architecture, the plan to establish a permanent lunar presence specifically to enable resource extraction, is built on a resource model that is now under revision. The European Space Agency's lunar resource programs, the China National Space Administration's Chang'e mission resource planning. Every major spacefaring nation on Earth has allocated capital and planning hours against a geological picture that just changed. Now let's talk about what this means for the technology itself. Because the problem is not just that the maps are wrong. The problem is that the mining equipment that has been designed, prototyped, and in some cases already manufactured, was designed for gray regolith. The drilling systems, the extraction mechanisms, the processing units, all engineered around the known hardness, density, and brittleness of gray lunar surface material. Pyroxene and olivine are significantly harder minerals. Higher hardness means higher wear on drilling equipment. Higher wear means shorter equipment lifespan before replacement or maintenance. In a lunar environment where every kilogram of replacement parts costs approximately $1 million to deliver to the surface, the engineering margins built into the existing equipment designs collapse. The machines were built for the wrong planet, or rather, built for the wrong version of the right planet. Run the second number. The average cost per kilogram to deliver payload to the lunar surface using current launch technology sits between $800,000 and $1.2 million. Redesigning extraction equipment for pyroxene and olivine mineral profiles requires new materials for drill heads, new torque specifications for extraction motors, new processing chemistry for mineral separation. The redesign and retooling cost across the industry is not yet fully calculated, but it adds to the $2 billion survey cost before a single dollar of revenue has been generated. Here is the deeper financial mechanism that ties everything together. The entire lunar mining investment thesis rests on a specific economic argument that extracting resources on the moon and either using them in space or returning them to Earth becomes cost competitive with Earth-based alternatives at a certain scale. That break-even calculation is built on known extraction costs divided by known resource yields. Both variables just change simultaneously. Extraction costs went up because the minerals are harder. Resource yields went uncertain because the distribution maps are wrong. When both variables in a break-even calculation move against you at the same time, the break-even point does not move slightly. It moves dramatically. The investment thesis that made lunar mining look like a 20-year path to profitability may have just become a 35-year path, or longer. And institutional capital does not wait 35 years for a return on a speculative resource extraction play when terrestrial alternatives exist. The sovereign wealth funds watching this are not sentimental about space. They are mathematical about returns. The moment the revised geological data produces revised break-even projections, the capital allocation conversation in those boardrooms changes completely. Not because space is suddenly uninteresting, because the numbers that justified the position no longer hold. Let's talk about what this means beyond the investment portfolios, because the consequences extend into geopolitics in ways that are not immediately obvious, but are already being quietly discussed in government strategy sessions. The Artemis Accords, the international framework for lunar resource rights that the United States has been building with allied nations, is premised on the idea that lunar resources are worth extracting and worth establishing legal frameworks around. If the resource extraction economics deteriorate significantly, the urgency that has driven allied nations to sign the accords diminishes. The competitive pressure that has pushed China and Russia to develop rival frameworks diminishes. The entire geopolitical architecture of lunar resource competition was built on the assumption that there was something economically worth competing for in the near term. The brown moon complicates that assumption in ways that take years to fully untangle. Meanwhile, the companies that were racing to be first to market now face a different calculation. First mover advantage in a market where the fundamental resource economics are under revision is not an advantage. It is exposure. The companies that moved fastest, spent the most, and are deepest into mission development against the old geological model are the companies most exposed to this revision. Speed became a liability the moment the composition data changed. Here's the number that ties the entire picture together. $500 billion of projected lunar economy value was built on gray. The rewrite required to align those projections with brown reality costs $2 billion just for the survey missions, then multiplies across equipment redesign, mission architecture revision, launch cost recalculation, and timeline extension. The gap between where the industry thought it was and where it actually is, measured in capital and time, is the largest single correction event in the history of the commercial space economy. And it happened not because of a rocket failure, not because of a regulatory change, not because of a geopolitical disruption. It happened because someone looked at the surface of the moon in direct sunlight and noticed it was the wrong color. The observation that changes $500 billion of projections was that simple and that fundamental. The math does not lie. Gray assumption, brown reality, $500 billion of reckoning sitting in the pipeline. The surveys that built the projections were not fraudulent. The scientists were not incompetent. They worked with the data they had. But working with the data you have, when the data you have is 6 sample sites across 38 million square kilometers, produces a model that is a best approximation, not a ground truth. The industry built $500 billion on a best approximation. Now the ground truth is arriving, and it is brown. There is no going back from this data point. The missions are already being planned, the mineral maps are already being challenged, the extraction cost models are already being revised behind closed doors in the strategy departments of every major space company on Earth, in the boardrooms of the sovereign wealth funds that backed them, in the budget offices of the space agencies that contracted them. The revision is happening now, quietly, systematically, and with enormous financial consequences for everyone who priced in the gray assumption. The moon did not change. The moon was always brown in the places where pyroxene and olivine dominate the surface. The maps were wrong from the beginning. And $500 billion just found out. I'm Daniel. This is Rolex Economics. If this breakdown changed how you see the commercial space economy and what is actually sitting inside those investment projections, share it. The people around you are about to hear about lunar mining opportunities without understanding that the geological foundation just shifted beneath every single one of them. Run the numbers. I'll see you in the next one.